So, who would like to show us how to do the first one? Okay. Thank you. So go ahead, if you've already got it up there, you can just use what you've already written, or if you want to, you can just go ahead and use the board there.
So we know that b sub 0 is 100, and we solve for b sub 1 in terms of b sub 0. So we move this term over to the other side, and you get b, we'll do, can everybody read that? I tend to write really small sometimes. Okay. So b sub t plus 1 equals b sub t minus 0.1 times b sub t. And then you get b sub t times 0.9, which is 1 minus 0.1. And that equals b sub t plus 1. And then you plug in b sub 1 is t equals 0. And so you solve for that, and that's 0.9 times b sub 0. And then b sub 2 equals 0.9 times b sub 1. Well, b sub 1 is 0.9 times b sub 0. So you got 0.9 times 0.9 times b sub 0. And b sub 3 is the same thing, but you got 1 extra 0.9. So you can solve it as, you can solve for t in terms of b sub 0. That makes sense?
Any questions? Okay, who would like to explain how to solve the other one? Okay, go ahead. You can just use the board up there if you want.
Can I use this one that I already?
Sure, that'd be great.
So I just factored the thing by grouping. And so then I have 3 factors. So my zeros are -2, 2, and 5. And then we just plugged in points outside of, or inside each kind of window, and found where the thing was negative and positive, and then kind of drew what the thing kind of has to look like. So
Where did you plug in the point?
Into this original equation, which might have been wrong. I think that might have been wrong. But then we came up with 2 unstable equilibria and 1 stable equilibria in the middle at 2. At b sub t equals 2.
Any questions? Don't be shy.
How do you know your graph curves were on?
Yeah, because of the negative and positive values. And I think that might be where I did it wrong, but because the value of the function isn't necessarily the slope, but that's what I did.
What do the positives and negatives mean?
It means that, I guess they're positive or negative values for b sub t plus 1.
Mm-hmm.
So,
And is that what we need?
no, we need the difference between b sub t plus 1 and b sub t.
Okay.
So I didn't solve for that, and I should have.
Good. Very good. Thank you. So how would we adjust things to make sure, check if we've got that the way we need it? Since we have found a little problem with it in that what we really want those plus and minus signs to mean is that there's a positive difference between b sub t plus 1 and b sub t, or there's a negative difference, so it tells us which direction b sub t is going, whether b sub t is going up or whether b sub t is going down. We need those values to be more slope values, not actual values of b sub t plus 1. It doesn't really matter if b sub t plus 1 is positive. What matters is it bigger than the one that came right before it?
I mean, you can take the derivative.
How would you take the derivative?
Can't you just take the derivative with respect to b sub t? I don't know.
Okay. Would that give us the answer that we want?
It's not the way that we've been doing this, I'm guessing now, but.
No.
If you find
There's this fallacy in math classes that somehow the way the teacher does this is the way or something. Totally bogus idea. Most of the time your teachers are teaching you the probably the stinking lousiest way of doing it.
Can you take the derivative of like the first equation and then plug in the values between the zeros that you found?
Okay. Now what would we actually be finding if we did that?
Would you have the implicit differentiation? Two different things.
Okay. We do have a dependence on t here as well, so if we wanted to include that, there would be some issues that way. But let's go back. If I just take that derivative idea, if we're going to take, we have b sub t plus 1 is equal to b sub t cubed minus 5b sub t squared and so on. We just take the derivative of that b sub t cubed minus 5b sub t squared minus 4b sub t plus 20 with respect to b sub t. Think of that as our variable. What would we be finding out? What information would we get? The rate of change of b sub t, and is that what we're interested in? Are we interested in how b sub t is changing?
No.
Hmm?
Yes.
Why?
Because if it's positive, if the rate of change is positive, then that means it's opening up.
Right.
And that's, you get that between 5 and infinity and negative 2 and positive 2. And if the rate of change is negative, then it's going down. And so you get that from 2 to 5 and from negative infinity to negative 2.
Okay. So let's take just 3 or 4 minutes with your groups, pursue that idea about taking the derivative and tell me what happens.
What happens to the b of t sub 1 when you take that derivative?
Yeah, what does happen to it?
Just a variable.
You're taking d db of t.
Yeah. Is it related to it at all?
So what?
Take 5 minutes, pursue the idea, see if you can come up. We know that we've got a flaw in the ointment here, a fly in the ointment, sorry. So now that we've done a little better job at kind of clarifying what our issues are, try your hand again at finding that, answering that question.